Welcome to lesson 3.5, dividing decimals. So this lesson is actually very similar to lesson 3.4, which was multiplying decimals, in that we're using the same strategies of using base 10 blocks, paper and pencil, and also calculator to learn how to divide decimals. So just as I said in the 3.4 lesson, the first section on using base 10 blocks, it's a very similar process to how you set it up in terms of multiplying decimals. However, that being said, I'm not necessarily going to do the lesson on it online, only because it's a little bit too difficult to draw out and to explain, and I'll just hold a mini lesson in class using the actual physical base 10 blocks. But in a nutshell, you would do exactly the same thing to set up your division equation using your base 10 blocks. You just have to remember what each one represents. So just a quick review, your kind of bigger square with 100 little units in it represents one whole number. Your rectangular one with 10 smaller units in it represents your tenths. And then your individual little units represent your hundredths. So again, you would just use these blocks to model your equation, and then use those blocks that you've modeled to find the quotient of your answer. Whoops, sorry, I'm not sure why that showed up there. But like I said, I'll do a mini lesson on that in class, only because it is a little bit more of a hands-on thing than it is to draw using this program, because I'm not, as I'm sure you noticed in the last tutorial, very skilled with drawing exact proportions using the program. So we'll do that mini lesson in class, but it is quite similar to how we did multiplication. The strategy that we will talk about today is, again, very similar to what we did with multiplication, but using whole numbers to divide instead of decimals, and then placing our decimal into our answer once we've figured it out. So I'm looking on page 105, and we're just going to go through an example of what that might look like together. So my equation reads 52.1 divided by 0.9. And so again, I'm going to follow the same process that we did with multiplication. My first step is going to be to make a reasonable estimate about what this might equal, so I have a better idea of where I'm going to place my decimal into my answer. So I'm going to look at these numbers and I'm just going to round. So I look at 52.1, and I know that's pretty close to the whole number 52. So I'm going to just round that to 52. And then I look at 0.9, and I know that's really close to one whole almost. So I'm just going to round that up to 1. So now I'm a little bit better equipped to make a more reasonable estimate, because I know that 52 divided by 1 equals 52. So that being said, I know my answer should be around 52, and that's going to help me know where to place my decimal after I figure it out. So this strategy, same as multiplication, I'm just going to essentially take the decimal out of my numbers, and I'm going to use long division to figure it out. So I'm going to use whole numbers. So if I have 52.1 divided by 0.9, I'm taking the whole numbers out. So 521 divided by 9, 0.9. Essentially, I don't really need that 0 there because it doesn't change my number in any way. So I'm going to set it up as 521 divided by 9. And then I'm just going to go through the steps of long division. I'm just going to use a different color here so we can kind of see the steps that's happening. So I'm going to ask myself, how many times does 9 go into the number 5? And I know that it doesn't go into 5. So then I'm going to say, okay, how many times does 9 go into 52? And I know 9 goes into 52 5 times. 9 times 5 is 45. And then I need to subtract. So 52 subtract 45, I know that I have a remainder of 7. And then I bring down my 1, and I'm going to go through the same process again. How many times does 9 go into the number 71? 9 goes into 71 7 times. I know that 9 times 7 is 63, and I'm going to subtract. So 71 subtract 63, I have a remainder of 8. But I need to keep dividing until I don't have a remainder, so I know what my answer is. So again, we talked about this in one of the earlier lessons. I can add as many zeros as I need on the end of this because it doesn't change the value of the number, especially when we're working with decimals. So I'm just going to add a couple extra zeros. We don't need to use them all. We're just going to use enough zeros until we don't have a remainder. So I have 8 remainder, so I'm going to bring down this 0 I've just added. I'm going to ask myself how many times does 9 go into the number 80? And I know that it goes in 8 times. 9 times 8 is 72. When I subtract, I'm left with a remainder of 8 again. And I'm going to bring down that 0. How many times does 9 go into the number 8? I know it goes in 8 times. 72. Oops, I'm running out of space here. And I know that 80 subtract 72 is 8. I can add another 0 because I kind of said I don't want to go until there's a remainder. However, I'm starting to notice a pattern that no matter how many times I go through this, that my remainder is always going to be 8 at this point, right? We have 8 here, we have 8 here, we have 8 here. If I keep going with the process, it's always going to be 8. So I know that this 8 is actually repeating. If I was to keep going, and I'm just going to do my math on the side, how many times does 9 go into the number 80? I said it goes 8 times. So I'm just going to continue the math over here. 9 times 8, 72. Subtract, I'm left with a remainder of 8 again. If I was to add another 0, so I know that this 8 is actually repeating. So that will help me with my answer. Because that 8 is going to go on forever, it's never going to stop. So 521 divided by 9, we have, like, with a few zeros, we have 5,700, and then the 8 keeps repeating. So now is the time when I'm going to go look back at my estimate, and my estimate is 52. So I need to place my decimal back into my answer somewhere. So what makes sense if I know that my estimation at the beginning was 52? I'm not going to put my decimal here because that would be 5. I'm going to put my decimal right around here because 57 as a whole number is pretty close to 52. So I know that that's probably a pretty reasonable spot for my decimal. So my answer to this equation is 57 decimal 8 repeating because we know that 8 goes on forever and it never stops. And again, the importance with this lesson as well as the lesson on multiplication is to use that front-end estimation to help you, because if you get an answer that is nowhere near your estimation, you know you might have maybe made a little mistake somewhere, or you need to go back and look at your math, maybe something happened, or you've placed your decimal in the wrong space. So that estimation is really going to help you with these two sections on making sure you have a reasonable answer. And if your answer is pretty close to your estimation, you know you're probably on the right track.